First levels questions should have been pretty, hopefully straightforward for most of you guys. It was 4/9, take away 1/3. The second question was 3 1/3, take away 1 1/2. Okay. So if you got this right and this level wasn't an issue for you, you don't have to take down any notes. Just watch, just make sure you know what you know. All right. So it's all about finding, with adding and subtracting, because they're both subtracting, but adding and subtracting, it's all about finding the lowest common denominator. That's the lowest number that both 9 and 3 split into. Now you could always do this question with a visual representation, of course. If I split 9 up and say, well, I have a whole box, and I'm going to just split it up into 9, and I'm going to just take 4 boxes of it. I know you've done this before, but it's always useful to think about it. At the moment, I just have a box and it's split up into thirds, and I have 1/3. And then straight away, you could get the answer here. But what we do mathematically is we go, well, if I had this box split up into 9ths as well, it'd be a lot, perhaps easier to count exactly how many I'm missing. So 4 of them, take away, well, 3 of them now, and you can see that. Okay, what we do with maths is we don't do visual representations as much because it just takes a longer time. There's nothing wrong with it, it just takes a longer amount of time. What we do is we find that common denominator of 9. So 1/3 is split into 3/9, because if I multiply the bottom by 3, I get 9, and I can't change it, so I must multiply the top. It's like the opposite to simplifying a fraction. Make them both larger instead of both smaller. Okay, and that'll be 4/9, take away 3/9, and that's 1/9. Okay, so that was the answer to the first one. So that's fairly straightforward and should be just really revision for you guys. Definitely should be a revision for you guys. This one can be approached in a couple of ways. There's some mixed numbers here, so whole numbers and fractions. Once again, you could split it up into boxes, if you want to just do boxes, and then we can do some subtraction there. And perhaps we'll do that for this example and then leave our boxes after that. So we've got 3 full boxes and 1/3 of the box. So these are full. We've got 1/3 of the box. So you have to split the last box into 3. Let's split it that way this time. We've got 1/3 of the box, so 3 full boxes. And then you want to take 1 full box away and a half box. Okay. So this is more of a problem where you definitely need a common denominator. So first of all, if I take away, shading in a bit better. The problem is if I can, 1/3 of a box, take away a half a box, is going to move into this full box over here. And that's an issue. So I can't just take away 1 box, because then there'd be not enough for this 1/3. So what I do is I try and find a common denominator again, and I split it up into, well, if I just go, okay, let's make 6 here, I also know that because they both are multiples of 6, that I can split this up into 6 as well. So I have a half at the moment, and if I split, well, I'll try to split it the same way. Let's change this a little bit into 6. Okay, I'll just split it a little bit differently so it looks like the same, so that's a half as well. All right, and then if I split all these into 6 as well, this is what we do. Split these all into 6 as well, and then we subtract how many we have. So how many 6ths do we have here? We have 6, 6, 6, and 2. Testing my times tables, so 6 times 3 is 18. Or sorry, yeah. 6 times 3 is 18, plus 2 is 26 we have over here, and then we take away, well, there's 6 here and another 3, so we take away 9 6ths over here. Of course, you haven't done this probably since year 3 like this, or maybe year 4. That gives me, so we just take away the top line, don't we? 20 take away 9 is 11, because we just have 6. How many 6ths we have is 11 6ths. You can put that back into a mixed number. We have 1 whole and then 5 remaining. 1 and 5 6. I think a lot of people got that yesterday. Most people got that yesterday. Okay. In the examples coming, we'll do is the method without drawing, but that's how you do it with drawing. Okay, so that was the level 1 questions, so the easier type questions. Well, should have been just adding and subtracting. The next one, level 2, was more, but maybe slightly harder, but pretty much the same level. 2 and 2/3. So we have 4.5 take away 2 and 2/3. And the other question in that level involves some multiplication. So 4 times 1.5 divided by 3. Okay, so we'll come to the multiplication and division in a second, but first, let's get over to this one here. All right, I'm going to do it the method that perhaps most of you did. I'm going to turn these both into improper fractions. So, how many halves in 4? There are 8. Maybe a quick way of doing that is do 4 times 2, and then add that 8 to the 1 here, and that gives me 9 halves in total. So the 8 and then the extra 1. So 4 times 2, add the 1. This one, 2 times 3, and add it to the top here. So 2 times 3 is 6, and then add it to the top. All right. And now we go find the common denominator. The smallest number of the 2 and 3 to divide into is going to be 6. So if I multiply by 3 here, that gets me to 6. You could do the cross multiply thing if you do that in this case. Multiply by 3. So multiply by 3 over 3, and we have 27 over 6. This one then, I need to multiply by 2 over 2 to get me to 6 here in the denominator. So remember, if you multiply a fraction with the same number above and below, numerator and denominator, you get the same number. It hasn't changed. It's just, it's still in proportion. It's still the same. So I get 16 up here, and then 27 take away 16 gives me 11 sixths. 11 sixths. Again, same answer. Or you could write 1 and 5 sixths if you want. All right. Over here, we've one that may involve some order of operations. I think the ones in level 3 involve more order of operations, but we know that multiplication and division have the same power in order of operations. It doesn't matter which one we do first. We should know that. Sam has them all done. Let's see if he's right. He's got the first 3 right anyway. Anyone else got some answers maybe for this one, the next 2, if you did them yesterday? All right, so multiplication, 4 times 1.5. Well, I could kind of probably do this in my head. 4 times 1 is, so I'm going to use the distributive rule, which you use in algebra a lot. You may remember that, or may not. I can split 1. This is just rough work up here. 4 times 1 plus 1/2. I want to do it that way. I split up 1.5 into 1 plus 1/2. And 4 times the 1 gives me 4, and 4 halves. Well, 4 halves of the pizza would be 2 whole pizzas. So I know that's going to give me 6, but perhaps you didn't do it that way. If you want to do it using fraction rules, I suppose, multiplying fractions, we'll turn them both into improper fractions. 4 is 4 over 1. 1.5, well, 2 times 1 is 2, added to the top is 3 halves, isn't it? So 3 over 2. And then I'm going to end up dividing that by 3 in a second. But I'll just do this first, and then I'll divide it by 3 afterwards. So I can multiply straight away and then simplify, or I can pre-simplify if I want, because I know 2 fits into 4. But I'll just multiply as is. 4 times 3 gives 12, I'm going to write it underneath, and 1 times 2 gives 2. So I'm left with 12 halves, 12 over 2, which is, of course, 6 divided by the 3 still. This is all just still to be divided by 3. I just included it. So 6 divided by 3 then is 2. Okay, so that should be your answer to that one. Okay. Oh, I gave you a different one, didn't I? Okay, that is an example of one question. I think you guys got 4/5. I think I changed that question since, but 4/5 is what you guys got. But that one, it'll only change from here on. So, oops, you're on 4/5. was using an older version of the same PowerPoint. 4/5 was here. Same thing applies though at this stage if the question was 4/5. This times this, 4 times 3 gives 12, 5 times 2 gives 10. So some of you are probably wondering why you got it wrong. It's because I did a different question. And then divide by 3. So I can simplify here if I want. 12 over 10 is 6 over 5, isn't it? If I divide by 2, divide by 2. Then divide by 3. Okay, so this time I'm going to have to use my knowledge of fraction operations. If I want to divide by a fraction, it's the same as multiplying by its reciprocal, if I turn it upside down. So it was dividing by 3 over 1, but if I multiply by 1 over 3, I should get the same answer. I will get the same answer. 6 times 1 is 6, 5 times 3 is 15. And then I can simplify again. Dividing by 3, top and bottom, gives me 2 over 5. So that's another. That was the answer you guys should have got. I did a different question. So 2/5. Let's see if Sam got that one. He didn't simplify, but he did get it. The only person who answers. All right. So we're moving on to the last level. 8 times 3, that should be obvious, multiplied by 1/3, all to be divided by 2/3. So remember, fraction is just division. This is just 2 divided into 3. This is 1 divided into 3 if you want to split up that. So this line here just means to divide. But I'd have to simplify the top first. This one. I'll come to the other one in a second. Okay, so let's simplify this top line. It probably could be done just by looking at it. If I take the end first, because multiplication, division multiplication is commutative. It doesn't matter which order you do it in. 6 times 2 is the same as 2 times 6. Same here. So 3/3 is going to be 1. So I think this is going to end up at 8. But if we want, we can just go 8 times 3 is 24, multiply by 1/3. Well, that's 24 then over 3, which is 8. So you can do that out in a longer way if you want. 24 multiplied by 1/3 over 2/3. And that will give then 24 divided by 3. It's 24/3 is 8. So we end up with 8 over 2/3. 8 divided by 2/3. So let's rewrite that in the kind of form we were using over here. 8 divided by 2/3. So I've rewritten that line the same. Okay, we'll use our keep, change, flip. Eight over 1, so we turn it into an improper fraction, multiplied by 3 over 2. Okay? Let's pre-simplify this, as in 2 fits into 8 4 times. I know that, so let's simplify it before I even do it. And then multiply in straight lines. 4 times 3 gives 12, and 1 times 1 gives 1. So 12 over 1, some of you might have got 24 over 2, and then divided by 2, but you can pre-simplify. Okay, so this answer is 12. And we'll do the last one, which is definitely the trickiest one, before I set you off on your way to do your work. Okay, so the last question was 6 2/5, take away 1/4, multiplied by 1 1/3, divided by 1/6. Okay. Well, this is where order of operations comes in. So this is part of this unit. You should remember how to do order of operations and BEDMAS. Most of you seem to remember it yesterday. Did someone else join there late? I think I see Robin now. Oh. Good. Okay. So let's do this multiplication first, because multiplication comes before subtraction. And reading from left to right, multiplication should come before division. So we've got to do this bit first. 1/4 multiplied by 1 1/3. So that's 1/4 multiplied by, let's change this. 1 times 3 is 3. Add it to the top, I get 4/3. 3 plus the 1. This is going to be 1/4 times. So I can pre-simplify, so divide here by 4. Divide here by 4, 1 over 1. Instead of multiplying by 4 and then dividing by 4, I just do it before I multiply. And I think I end up with 1/3 of this. 1 times 1 on top and 1 times 3. Or you could end up with 4 over 12 and then simplify. All right, let's bring down our other numbers. 6 and 2/5 still in play. And divided by 1/6 at the end is still here. I'm going to have to do my division first. 1/3 divided by 1/6. Interesting. Difficult to visualize that, perhaps. 1/3 divided or divided by 1/6. Wonder how that would look like with boxes. Sorry, my other laptop is running out of charge. Okay, so 1/3 divided by 1/6. Let's think about that. 1/3 of something divided by 1/6. Well, we could probably visualize that in boxes, which we may look at in a second, but even just thinking about it in our head, I think 1/6 fits into 1/3 twice. It'd be 2/6 in a third, so I could probably just work that out in my head. 2. But if you want to do it with a method, 1/3 multiplied, change by the reciprocal, 6 over 1. Remember that word reciprocal, it means to flip that fraction. Akil thinks it's 1/3 multiplied by, yes, it is 1/3 multiplied by 6. All right, so let's do that. That'll be 6 divided by 3, which is 2. So it's 6 now, and 2/5 still. Take away 2. We've simplified, and we're down to this. So 6 and 2/5, take away 2 wholes. That's just going to be 4 and 2/5, isn't it? Don't need to make it more complicated. The answer to that one is 4 and 2/5. All right, so that's our methods. The key things here. Number 1, with multiplication, you multiply in straight lines. You can pre-simplify if you want, like I did here, or you can simplify afterwards. Division, remember to keep the first fraction. Where is it? Keep the first fraction, change the sign to multiply, and flip the second one. For addition and subtraction, get a common denominator, that's a common multiple of both numbers below the line, and then once you've done that, you can add and subtract just the top line. Okay, so the keys for each of those. Right. So what you guys have got to do now is you probably have seen on Manage Back. I'm just going to stop this recording.